Hello everyone, welcome back to another episode of Tantra's Mantra where we go behind and beyond the tech news headlines. I am Prakash Sangam, your host and founder of Tantra Analyst. Today we take a small detour. Instead of going behind a news headline, we go behind a major trend in one of the fascinating industries. I'm talking about automotive industry here. No, I'm not talking about autonomous driving or electrical vehicles. Instead, I'm talking about another equally important trend that actually underpins those two very hype topics, if you will. Let me explain. It would be an understatement to say that auto industry is in the middle of a major transformation, something that you see once in a generation. The automotive itself is being transformed from a mostly mechanical machine into an electromechanical gadget driven by SoCs and software. Some people even go back to the extent of calling modern cars smartphones on wheels. A biggest trend in that transformation is what is called domain consolidation. You see, most of the electronics in today's cars is supported through what are called ECUs, electronic control units. These are single function modules made from simple microcontrollers with limited processing capability. And you will find tens of these in a typical vehicle, could be even 100. For example, there are different ECUs for braking, power windows, roofs, instrument clusters, and so on. But with increasingly more and more technology going into cars, especially on the entertainment side, the processing needs are increasing exponentially. In such case, the best option is to replace these bunch of single function limited capability ECUs with few super powerful SoCs. That's exactly is what domain consolidation is. But it is of course easier said than done. To discuss the issues as well as its challenges and opportunities, we have two industry veterans from two leading companies in this sector with us today. And they are Stefan Buerkle, Head of Sales, Cross-Domain Computing at Bosch North America, and Shyam Krishnamurthy, VP and Head Automotive Compute Business at Qualcomm. Stefan and Shyam, welcome to the show.
Thank
Thanks
you.
for having us.
Thank you, Prakash.
Thank you for coming over. Let's start with quick introductions. Could you please give our listeners a quick background of yourself and what you are currently responsible for at your respective companies? Let's start with Shyam and then Stefan.
Hi, my name is Shyam Krishnamurthy. I am responsible for automotive compute platforms at Qualcomm. That includes both cockpit, which is what you call infotainment, and cluster side of things, as well as autonomy and ADAS compute.
Thank you, Shyam.
Yeah, my name is Stefan Buerkle. I'm here at Bosch North America, responsible for sales in our cross-domain computing division, which includes most of the electronics and software for all our vehicle solutions. As well, I'm responsible for the business units of interior domain computing. This includes all the domain computing electronics and software, as well as clusters, ECUs, driver, and occupant monitoring.
Thank you very much again for coming over. Let's get started. What are some of the top challenges you guys are seeing in your respective areas as auto players?
Maybe let me start on that one. So from my perspective, the two top challenges, and there are many of those, one is the speed of innovation. Based on an Invensity study, 90% of all automotive innovations result or come out of the software electronic space. So to keep up with that speed is really key. The other one, and you mentioned it before, is the complexity. If you think about 2010, a vehicle included somewhat around 10 million lines of code. While we are today without autonomous driving already around 100 million lines of code, our projection is that this will go up to 300 to 500 million. And that drives, of course, a lot of things we have to consider. And this is also one of the topics we will talk to today, how we can solve that together with the collaborations we have, for example, with Qualcomm. And last but not least, to the complexity we have in the premium car segment, we have now up to 100 ECUs. So this is one of the drivers why we need domain consolidation, as it's really difficult to handle this huge amount of ECUs. If you think about the complexity in communication between the ECUs and in managing them, that they work together perfectly, but also purely from a topic of a wire harness. So those are topics I think we will dig in deeper today.
Thanks, Stefan. Shyam?
Yeah, I think to again continue with what Stefan has said, you mentioned smartphone on wheels. I mean, I think that paradigm is probably correct in terms of the user experience that is demanded by the end user, but the complexity is way higher in the software and the hardware than a smartphone. We have many more displays, multiple operating systems resident alongside each other. Then it is a standard platform, right? No, it is a very fragmented ecosystem. There are many variants of Linux. Of course, there is safe OSs that we need to support, QNX, Open Synergy, Green Hills. Of course, multiple variants of hypervisors. There are several types of them. So as a platform supplier, it is a significant complexity. Only a very strong software company can actually engage and deliver on time these products in the market. So the complexity level is in the software far exceeds what we have seen in other markets.
Yeah, of course, there is no shortage of challenges. And apart from the technology challenges that you mentioned, there is this chipset shortage challenge as well, right? And Qualcomm's CEO, Christian Amon, said this might extend till end of this year, even early next year. So how is this shortage affecting you guys? What are some of the mitigation strategies that you have in place?
I'll start first. I think Stefan can talk about his challenges much better, but what we have done as Qualcomm, actually, we need to thank Cristiano and team for supporting this. We have prioritized the automotive business. So Qualcomm, as a supplier of over 1 billion chips a year, has a lot of leverage and also has a lot of capacity. So that message that we have communicated to our partners is that we are getting kind of the first dibs on what is available from the Qualcomm's supply chain. And that has been very important for us to support our customers.
Yeah, let me jump in. I mean, the semiconductor crisis is an industry-wide challenge, which we not face only in automotive, but heavily also in the consumer electronics. There was multiple factors leading to the situation. It's not only the supply, it's also demand side driving it. And different factors include the digitalization, the market behavior. We had natural disasters, not speaking about the pandemic. So this is not a short-term topic, and then like Shyam already highlighted and you mentioned it, this will not be completely over this year. This will definitely work and go into the next year as well. I mean, what we do is we actively work very closely together with our customers and our suppliers to manage this challenge and keep the impacts as little as possible to all involved parties. But yeah, as said, this is not a short-term topic and will keep us busy into the next year.
Okay.
I think to weigh in what Stefan is saying, like you mentioned, every opportunity for Qualcomm is also a challenge in the sense that it is a multiple compute opportunity in the car, for example. As a supplier to compute, we already see that in several OEMs that, people want to keep the software the same across multiple platforms. They like what we provide as Qualcomm on the software side as well. So they want to use us in many, many different ECUs. So this then becomes a single ECU supplier becoming multiple ECU supplier. And at the same time, the capacity is constrained. So it's very important that we keep a very close track of this. And this is a multi-year problem because right now, if you look at the car electronics is actually growing much faster than the market, at least 3 times faster than the overall market is. So, and that's really causing the significant pressures in the back end. And automotive electronics is not the same as commercial electronics. We go through much more rigorous qualification cycles, and we have much more rigorous standards with respect to the suppliers. So that's also adding to the challenge.
Yeah, I agree. It's not easy ramping up, when you compare to other industries. It seems the shortage and the effects of that are going to be here for some more time then. Okay, so let's jump right into this domain consolidation. I'm sure I oversimplified it when I introduced it. Maybe you guys would like to add some more color to it and also let us know what is the current status in the industry.
Yeah, maybe I give a quick outlook. The domain consolidation already started. We are in multiple projects which we develop for introduction into the market starting next year and then following every year, in which we already bring different ECUs, which are today's standalone ECUs, together in one domain. To give you an example out of the cockpit side, we are launching next year a project which already combines all infotainment and all instrumentation, but not only these two pieces, but also already includes different driver assistance functionality all out of one box. And the key here is that it's not only one box, it is one box with multiple PCBs and maybe multiple SoCs. Like Shyam highlighted before in the complexity, so it's based on a hypervisor solution, which then runs multiple operating systems, which then are focused on the different, let's say, jobs we have to perform, right? We have the infotainment space with a lot of connectivity, the app side, the services and features, HMI. But then we have the cluster side, the instrument cluster, which has much more safety and security features in there. Not that the other side don't have to be safe, obviously, with all the connectivity to the outside world. Security is one of the key players that we have to focus on. But in the cluster domain, you have to go sure that all the telltales, all the warnings are always displayed because it's fully digital and not hard-coded. So we bring these together, and then you have the driver assistance world features to support them in parking situations or in visualization of the car, like surround view. So we already bring that together. So it's happening. It's not something on the horizon. It's really happening now and starting across the industry.
That's great.
Yeah. To add to that, in a broad sense, there is a combination of displays and cameras, and there are in-car cameras and out-of-car cameras, and of course, machine learning to go with it, because all of them need to have detection and inference functionality. And so we are talking about, just for assistance function, 8 or 11 cameras, and for display functions, 6 to 10 displays, all running on a single SoC. So in terms of the performance for just this domain consolidated ECU, we are actually significantly more taxing on the system. But of course, these all have to be in multiple different virtual machines and domains. They need to be separated for safety reasons or whatever other reasons. And in many markets, including in China, you will need more than one operating system, right? So they have their local ecosystems that need to be supported. So this is really just a sliver of the consolidation that is already happening. But you can already see Snapdragon cars commercially shipping from last year, where there are lots of these consolidations already happening. I have a car myself that has the cluster AR HUD and the cockpit and the audio and all those things functions resident on single SoC, hypervised with multiple operating systems. So
very well. So it seems it's well underway, and I'm assuming it's across all the OEMs. It is not strategy or approach of one OEM towards the other, right? It's happening across the industry, I assume.
Yeah, the timeline is different in each OEM, but in general, this is definitely a market trend we see.
Okay, perfect.
Yeah, one important area, that because I run both cockpit as well as ADAS, is important area is that a lot of the assistance functionality, safety critical assistance functionality, is also coming in aggressively. And as Stefan mentioned, it is really OEM driven, and the time scales are different. Some people are already shipping products, some will do next year. I know over the next 3 or 4 years, there is a lot more of this happening at multiple OEMs in the world. Some are still conservative, that they are integrating other functions, but they're not bringing certain other functions together. So again, points to the fragmented ecosystem. It's not a one solution fits all kind of a model. And so the software, BSP, and the development that we do has to cater to each OEM's requirements separately. Yeah.
Well, that's interesting. So what are kind of some of the top benefits to the OEMs of this consolidation?
Well, the benefits are multifaceted, right? There is the one side is the need side, because the complexity we talked about is getting bigger and bigger, and to have the domain consolidation and bring pieces together and drive them from one SoC and out of one system reduces that complexity. But then there are other benefits. If you can imagine all the communication between the boxes, all the different data sets we have, having them more centralized, available. It's not that it now finally enables additional services and functionality, but it makes it much easier to drive them once you have them all in one place on a standardized output. And then there are other benefits. Think about space, think about weight, think about, I mentioned it before, the wire harness and how complex they get. So think about the testing. If you have to test how 100 different ECUs from different suppliers all have to work together, that drives really also complexity, cost, and time. So you can see it goes in multiple different directions. And let me add one thing. Often it is asked, why now? Why not before, if it makes so much sense? We talked about the sheer amount of calculation power we need and how complex the software gets. The benefit is really coming, and I touched 2 times shortly on it, is when you can drive that from one SoC. And this is where strong companies like Qualcomm come into play. That is a lot of calculation power we need in those boxes as we bring them all together. And therefore, this development of centralization and UE architecture goes closely in line with the platform development on the SoC side. If it comes to CPU, GPU performance, if you want to drive 10 4K displays, that is a lot of calculation power you need on the GPU side. So therefore, it's closely aligned with also the progress on the SoC side. And secondly, on the software, it is not a one company challenge. In the past, in a very traditional model, an OEM specified a system he needs, and then the tier one designed it, developed it together with some partners and suppliers, and delivered it to the OEM. Meanwhile, it is much more of a team activity. If you look into these boxes, everybody contributes into it. The OEM has certain software stacks they develop in-house and want to carry over from generation to generation, while there's a lot of software we as a tier one are bringing in, building all that together. But then there's a big amount of software also coming from the partners like Qualcomm, from the base software up, and then different features and functions coming from different companies. So it is really a team challenge, and therefore it is so important that you gained experience in working together and are aligned in the process, in the tools you use, in the methods, how to share software. Those are all, you think, small things in the beginning, but it can take a lot of time if you're not used to work together.
Shyam, anything to add? Or?
I mean, I think Stefan said it very well, and Bosch is actually leading in several areas, including autonomy and cockpit, so they understand it very well. But the big challenge that we always face is, how do you drive mission critical latencies through the system? And especially, our partnership with Bosch, with their learning in, several of these areas, not just informational, because some of these informational safety features are very important, like, vulnerable, road object, or somebody on the road walking towards your car, etc. You need to deliver that information to the driver very, very quickly. And so a lot of the challenges are around how do you manage the latencies through the systems, and what are the kind of the actuation times in the car, etc. So working closely with partners like Bosch, who are the leaders in this area, Qualcomm is also learning a lot in how to architect these systems to do much better at delivering these latency and performance levels in such a complex system. So it's a very difficult, challenging problem, but with the right partners like Bosch, I think we can solve this very, very well and provide a lot of very strong features in a consolidated box. And also, consolidation is not just done for cost, it's also done for the ability to do what I call service mashups. So you can create unique experiences by combining functions in the car. And also it simplifies the software cost of ownership for the OEMs significantly, because they don't have a whole bunch of spaghetti code running across the car that they don't know who developed or how they maintain it for 15 years. Here, the ownership actually is within a few people and with the OEM itself as well. And that's also a significant trend we are seeing right now.
Yeah, it seems it is simplifying a lot of complexity, but at the same time increasing the complexity as well with so many functions and so on. So, do you see any trend in standardizing in terms of architecture and so on, or do you see OEMs driving their own strategy and vision in terms of bringing this to fruition?
Well, there's, let's say, an overarching trend of a zone architecture in which you have different zone computers and then zone modules. So the overall trend is a similar one. But then if you look into the different OEMs, everybody has a specific flavor because there is not the one conclusion of which ECUs have to be brought together in which steps. Right, we are not moving from 100 ECUs to one car computer. Right, that will go in steps, and we project that we move into like 4 to 5 domain computers. Then as a vision, there is still this one car computer, but that will be further out. Now it becomes interesting. How do you move from the hundreds to the, let's say, 50 to the 25 to the 4? And here every OEM has a slight different approach. Some focusing more on bringing all types of displays together in one box and combine it maybe with some interior and exterior cameras. Others are focusing, maybe integrating a rear seat entertainment, talking now mostly about the interior side. And then others leave that away and bring more driver assistant functionality in. So even though everybody is up integrating, let's say minimum most of the OEMs, everybody has a slightly different approach to it. And then also Shyam mentioned in the beginning, even though you would bring the same pieces in, there are so many different variants how you can do it. If it starts with, you could do it in a container solution, which basically does not use a hypervisor. You could do it on a hypervised solution, but then within the hypervisor, there are different, not only vendors, but then there are different architecturals, and each of them has benefits and their disadvantages. And depending on the OEM, their car segment they're in, the markets they are in, they go into different directions. And that drives, of course, the complexity also for us as a supplier and the partners working with the OEM. But what helps us a lot is we are in all the different fields of electronics in an automotive. We are not only an infotainment supplier or an instrumentation supplier or a body control module supplier, gateway, driver assistance, all way level 2 to 4, all those different pieces, and there are more to it, perfectly keyless entry solutions. All of those things come together, display knowledge. So if you want to up integrate, it's really challenging if you don't gain this experience in a single domain over the last 10, 15 years to bring it together now. And this is a strength we as Bosch definitely can bring in and utilize also our great collaborations with Qualcomm to execute and build systems which are efficient. You can quickly build a demo together and have some things running, but to build it in a series-ready, efficient way where you optimize latencies, where you optimize heat management, that you don't need a fan or don't have to shut down the features and functions in heat situations. This is where the complexity at the end comes in, not to quickly stitch together a demo.
I think it's a very valid comment, in terms of, very important to also understand that even in a car, because there are so many concurrencies that we need to plan for, power has become very, very important. Qualcomm being a leader in power, especially with respect to platform and SoC power, we are addressing it, head on, because a lot of our IP blocks are built for low power. And when they all come together, power has become a significant enabling technology because the concurrencies are so high that a single box is not able to dissipate the high power demands of the performance that is needed to drive these concurrencies. Yeah.
And also, I think the question that you raised about power is really important because, especially when you look at electric vehicles, battery life is one of the key performance criteria, right? So the less power you consume on the electronics, then the more range you can give, and that kind of defines the overall experience.
I think battery life is important, but also operational life is important, especially in systems which are, safety critical. The operational life is impacted by how much power you dissipate and how hot it gets. So these electronics need to last a longer time.
Correct.
And if you're dissipating a lot of power for a long periods of time, your lifetime diminishes. And that is also important. So the low power SoC technologies have become mission critical for automotive electronics right now.
Okay, cool. And you see this consolidation happening across the tiers. Probably the level of functionality that you support and other things might be different in different tiers of the cars, but you do see this happening across the, not just at the premium vehicle.
Yeah, it's definitely a cross segment. The E architectures are usually used in all the cars, and different segments have different levels of the same E architecture. Of course, you scale within the domain computer, so therefore it is important that, like with Qualcomm, the Snapdragon family has a certain scalability so that you can run more or less same software on one chipset family, so that in the lower segments you use the lower performance chips, and then you can scale it up to the premium segment, because you cannot develop standalone domain computing units for each segment. The effort would be far too big. So scalability is key. And another topic we didn't touch yet but I find this is an interesting one, and also a challenge, is to be future-proof, right? In the smartphone, which is often now compared, and we touched it, the people are used to that. They get every 2, 3, 4 years a new smartphone. Every, I don't know, 5 to 8 years. If you cannot get the latest update because you have not enough memory, it's somewhat expected and accepted by the market. If you look into automotive, the expectation is a different one. If you buy a car, of course, the investment also is significantly different. Your expectation is that a car after 8 years, 10 years is still fully functional, and you still have the latest, greatest features. So when we design systems and with FOTAs or update over the air, we have the possibility to keep the fleet really up to date on a more or less day-to-day basis. So how do you design a system which is not only fresh and up to date and performant at a start of production, but also SOP plus 3 or 5 or 7? So this upgradability and future-proof, to have enough headroom for future demands, that is another challenge we all work together on.
Yeah, I think it's a very important point Stefan has raised, and Qualcomm has an initiative called Car to Cloud, which primarily looks at this life cycle maintainability of the performance levels and optimizations and downloadable applications. And as the ecosystem gets richer on the car side, and as I mentioned, the ecosystem is getting very rich and also very diverse. It is very important to develop technologies like what we have done, which allow us to manage those performance demands, and not just for 2 years, but for 7, 8 years, and how to easily upgrade the software and have the same experience over time. So I think what is happening is that is actually maxing out the performance levels right now. But then, of course, as we develop better optimizations, the ability to download it over the air, we can then upgrade the performance on the same silicon over time. So there is also a lot of headroom that is needed in the silicon. So across each tier, there is a certain headroom requirement as well that we need to cater to from our ecosystem partners such as Google, etc., to also our OEM partners who have feature rollout plans that are beyond the SOP dates, because they are now able to upgrade over the air. So this is a very strong and long planning cycle, and the OEMs are also trying to increase the capacity that they put into the cars already, so that they can actually also monetize these functions, features, and services through the life cycle of the car. So I think there are benefits to the OEMs in that sense as well.
Very well. So, talking about benefits, let's move on to the user side. Tons of benefits for OEMs with consolidation. But as a end user, as a car driver and owner, why do I care whether there are fewer chips in the car versus lots of chips under the hood of the car? Are there any user benefits as well?
Yeah, as we talked earlier about the benefits to the OEM, of course, the end customers will, in the one part, indirectly benefit out of it, right? If we have less weight in the car, your fuel efficiency goes up. If you have more space in the car, you can utilize it to either include other things or maybe optimize the interior of the car to make it even more user-friendly. So there are these indirect benefits. And then Shyam already touched it a little bit. The direct benefits is on the features, functions, and services side. The upgradability in future from a FOTA side is easier. The data availability I mentioned before. If you also compare that with the smartphone side, the speed of innovation went so much up quickly when the data became available. Right, you tapped in the whole creativity of the app developers around the world, which came up with a lot of ideas what you could do. So especially in that area, we will see a definite increase in the segment around features and functions, which that will be the main visible, let's say, improvement within the car.
Okay.
Yeah, I think the user benefits are clearly greater customizability, and it feels like it is one system and one software. And traditionally, it has not been that kind of an experience in a car. I mean, if you looked at where the systems were, even the instrument cluster was different from the cockpit, was different from the RSE, came from different companies running different software. That one user experience and the ability to, customize it and create mashups between these systems didn't exist before. So I think now the user will feel that it is one type of experience they're used to on a phone, for example, on every screen in the car, for example. So, and the AR HUD is working in unison with the cluster, with the IVI and certain functionality and the maps together rather than as disjointed systems. Yeah.
Okay, very well.
Let me add one thing on the digital
Sure.
services, because that's quickly, more services. Based on a Bitkom study, it was performed in Germany, but I think it still reflects a global picture. The digital service is the highest ranking criteria of a decision to buy a car, with 93%. Picture that the purchase price of the car ranks second with 91%. So this is an important field and a huge differentiator opportunity for the OEMs to improve the service sites and really important to the end customer. So we should not underestimate this impact.
Yeah, I mean, people talk about, in China, they call it the internet car, right? So I think the experience they have in the car while they are not looking at the phone needs to be similar or better and with a lot more kind of NLU and voice activation to, different way than touching the screen, but needs to provide the same functionality or better functionality on the road. So I think that is what is driving the car purchase decision right now. So
Absolutely, yeah. I mean, nowadays, for especially the younger buyers, the tech in the car is more important than it's the engine performance and so on.
Goes together with the trend of urbanization. You live in big cities like New York or Shanghai or any of those. It is not the key point if your car can go 100, 150 or 200 miles an hour. You won't be able to drive that in the city.
Correct.
But how connected is your car? What can I do with the time in semi-autonomous and ultimately autonomous driving situations? That is really key.
Very well. Okay, so as major players in automotive market, what are some of the things that you guys are working together on and collaborating on? Specifically, I know at a general level you work on many systems, but specifically, what are you guys both working on?
I mentioned a few examples in the interior domain computer side where we have multiple projects together launching in the next 12 to 24 months. But obviously we utilize this strong collaboration also in different fields where we work together. In general, we exchange on basically all the electronics business and see how we can utilize the offerings from Qualcomm, not only on the SoC side, but also from a software perspective or the additional features and functionality like car to cloud.
Yeah, I think, I echo what Stefan said. Bosch is a valued partner for us, and, we have several leading edge programs doing a lot of the zonal compute architectural work together before the OEM request comes in. And we also do a lot of work in the ability to scale these things up in terms of, pre-development, maybe even before even silicon comes in, simulation, etc., to add these functionalities to understand the use cases and concurrencies, because for us as a chip supplier, we need to be able to address the concurrencies not just at SOP, but as we mentioned, beyond. So we need to be able to develop architectures and systems on the chip itself that can actually foresee some of these and address those demands.
And in terms of a roadmap, where do you think this collaboration is moving towards? Any moonshot goals kind of things you have together, or it's going to be a incremental development phase and so on?
I think as Sean mentioned, the key is this upfront collaboration, because to start working at a day of where an OEM decides to source a certain system, it is too late. If you start at this day to work together, you will lose so much time. You have to start and start a collaboration much earlier to be ready to support the time to markets which are required meanwhile. And here we utilize this collaboration. And for example, we talked much earlier about car to cloud before even any OEM started to look into it, so that when the OEM is ready, we are prepared for execution.
I think that there are moonshot goals. Of course, people already smarter than me have defined those, that you want the car to drive itself, and and most of the time all you're doing is playing games. But I think we are trying to address the real world use cases where the experience in the car becomes very, very pleasant for people. Right now, the commute is a bad word, but I think the goal is the commute needs to be a safe, importantly very safe, and a very pleasant experience for most people in the car. And I think we all have the same goal. Safety is the most important, but of course it also needs to have. We are selling a lot of entertainment solutions, and more importantly, also ability to do more work in the car while you're driving as well, and how that can be facilitated through user experiences, assistants, intelligent assistants, and things like that. So I think there's a lot of innovation happening here, and you will see that roll out in cars, short term and long term.
Because you mentioned both things, and they have to go absolutely together, right? Entertainment and safety. Entertainment in the nature is distracting. That's the sense of entertainment. It distracts you from your day-to-day living, your day-to-day job, and tasks you have to do. So when you want to be entertained in the car, it has to be, and that's priority one, in a safe manner. That's the first and utmost important one before then the entertainment starts, especially in the phase where we transition from fully self-driving via driver assistant functionality all the way up to semi and full autonomous driving. As we progress in this line, we always also will progress on that entertainment side and connectivity and services and your social life, but that has to be closely linked, so that it's always in a safe manner.
Excellent. Safety and entertainment. That I think is a great way to conclude this conversation. Once again, thank you very much, Stefan and Shyam, for coming over and sharing your views. It indeed is fascinating to see auto transformation happening in front of our own eyes. And you guys are fortunate enough to not only take part in it, but shape it as well. I hope to see you again on the show in the near future to discuss the progress of this transformation. Thank you.
Thank you so much.
So, folks, that's all we have for now. Hope you found this discussion informative and useful. If you did, please hit that subscribe button down there on whatever platform you're listening this on. Again, I will be back soon with another episode, putting light on another interesting subject. Bye bye for now.